Welcome to Success Academy. Okay, so for today we have 2021 paper. Okay, so that was written in November. So this is pure physics 5054. Okay, so we have a segment of question 4, which I took from the topic of waves. Okay, so we explore through some principles. Okay, and then also look at different diagrams relating to destructive waves. Okay. So the question states in question 4, figure 4.1 shows two identical loudspeakers placed facing each other. Okay, each speaker produces sound at a frequency of 1500 Hz. Okay, at the same time, the maxima of intensity are formed at regular intervals along a line joining the speakers. So we have the particular form of speakers which are facing each other. Now these speakers, they will form an interference. There is some interference that is formed when the two waves are coming from these two speakers. Okay, so that can be reviewed by looking at the principle of superposition. So we have the principle which we call the principle of superposition. So this principle states that when two or more waves overlap in the same space, the resulting wave is the algebraic sum of individual displacements. So that's what this principle states. Okay. So if we see from the diagram in terms of representation when the waves are facing each other, okay, so those waves, they will form a destructive interference. Okay, they will form what we call destructive interference. So destructive interference can be described to be it occurs when the crests, okay, and the troughs align in the way that waves effectively cancel each other, okay, resulting a smaller amplitude or even zero amplitude. So we can I will try to represent the diagram, okay, relating to destructive interference. Okay, so let's look at the diagram. So this is the diagram representing destructive interference. So this is a crest. Okay, we have a crest and then we have a trough. So we have to know that this particular crest is on the same magnitude as this trough from here. Now, when these waves, for example, they interfere or they come into contact, basically they will overlap and then they will cancel each other. And then what will happen? There will be a combination there. Okay, so the combination will result into zero magnitude or zero. There will be zero amplitude. So the amplitude will be smaller or zero according to the previous principle. If we look at this part here, so the amplitude or will become smaller or even zero. Okay, so that's what will happen. So what we have in here, when there is a combination A plus B, there will be zero amplitude. So this is the zero amplitude that is being represented. So this wave, for example, in a red form is represented in that form. So the amplitude is becoming zero. And then also here, the one which is in blue form, here, basically, it will become zero. So after this, after the meeting up of the particular waves on this point, when the waves, for example, pass each other, they will continue in their same forms, okay? They will continue in their same form. So if we see this red one will go to this side. So if it is the wave from this speaker, it will go to this side, okay? After meeting up at this point, they will continue their journey in terms of wavelength, okay? So that is the particular basic which we have to know when it comes to superposition, destructive interference, and so forth. But for constructive interference, I'll find the question and then I'll talk about it separately, okay? So let's look at the first question that is being given. So in our first question, we are told that the distance between successive maxima is 0.11 meters. Okay. In the first question, what property of waves is responsible for the maxima? So we call this as interference. Okay. Yes. So therefore, on B, question B, we go to question B. Determine the one wavelength of the sound wave. So when you are calculating the wavelength of the sound wave, these waves which are combining up, so we'll take it up from this point. So add the two the two interfered waves, okay, to find the particular wavelength of the wave. So therefore, the waves will be in combination. We'll say 2 times 0.11, okay? So when we multiply 2 times 0.11, then what we have is 0.22 meters. So this will be our answer. Okay, so please consider subscribing to the channel, okay, as we are moving on, okay. Then comments, you have to put comments in the section if there are some questions, some queries and so forth, okay. So let's look at other questions which are present. So question 2, we are told um, to calculate the speed of the sound wave. So how do we calculate the speed of the sound wave? So when calculating the speed of the sound wave, basically we use the general wave formula. So this is our general wave formula where we have wave speed is equal to frequency times the wavelength or lambda. Okay, so this is the general wave formula. So now we begin to collect the data. Okay, so our wave speed, if we look at our wave speed provided, we are given, okay, we are not given the speed of the wave, and then frequency, we are provided with frequency. So we can see from here that the frequency given in the question, if we review the question, figure 4.1, okay, shows two identical loudspeakers pressed facing each other, okay. Each speaker produces the sound at a frequency of 1500 Hz, okay. So this is the actual frequency, okay. So our frequency present given, we have 1500 Hz. And then what are we given as the lambda, or sometimes wavelength, this particular lambda. So lambda is the wavelength. So if we look at the previous parts, we are given the lambda or wavelength to be 0.22 meters, okay. So therefore we set this in the formula, okay, and then from there we find the answer. So we'll state 1500 Hz times 0.22, okay, which is the wavelength, and then this is the frequency. And then what we have afterwards is 330 meters. So we have to write in the answer section there. Okay, it is important because most of the markers, sometimes they can reduce marks if you don't write in the answer section. So therefore, we have the speed of 330 meters per second. Okay, so we come to the last question here. What factor affects the quality of sound? So the factors that can affect the quality of sound, we have one, the amplitude of sound, and then we have distance from the source to the listener, if the listener is a variable, okay, and then also we have the surface area of the vibrating body. So these are some of the factors that can affect the quality of sound. Then we come to an end for the session, okay. So thank you for watching, everyone. And please consider subscribing to my channel, okay. Follow the channel, okay, share the link on to others, okay, as they continue to support the channel, okay. So thank you for watching.